All right, this is the lesson I was talking about. You need the book in front of you. You need to understand where to look and where to go from there. My graphs aren't as good, but it's better in your book. Here we're learning about graphing quadratic functions. Quadratic functions, meaning is the ax squared plus bx plus c, those things that you see when you factor. But in this case, you're not going to factor. You're focusing on the x squared. X squared always creates a parabola. It's like a u. So they always create a parabola. So if it's y equals x squared plus this whole thing, or just y equals x squared in general, it always equals a parabola. Here are the steps to solve for it. So if you need time to press pause and to take a picture or screenshot it, this will be very helpful for today's lesson. I do want you to graph. I'll send you on under the bio over here. I'll show you an app you can use to send it to me through PDF, because if you don't send it to me through PDF and you send me a picture on your phone, I can't read it and I'm going to count it as a 0 because I can't read it whatsoever. So I have to use it as a PDF. There's a way you can do it with your iPhone through Notes. If you take a picture through Notes, it scans your notes and it sends it through PDF through my email, and I'll have it down there. I always have it on the homework as well. But I need it through PDF and through email. You only have within about 2 days to complete it. So just make sure you have those steps down. Here it says find the axis of symmetry. That is the equation equal to x is equal to negative b over 2a. If you notice, the a is in front of the x squared, the b is in front of the x, and the c is a constant. The second step is you find your vertex, meaning once you have what x is, you plug it into the original equation and you solve for it, and you're going to end up with a coordinate. And the vertex, meaning that's the starting point or the ending point of your vertex. It's right in the middle. Third one is your y-intercept. That's your c. Your c is considered that last unit here. So you're always going to have 0, comma, whatever your c is. If you don't have a c, so if it's y equals x squared, your c is considered 0 because you don't have one. But there has to be a number there. So every equation has a c. The fourth one is choosing an x value, left or right from the vertex. Once you're graphing, and you're graphing each of these step by step. So once you're graphing, you'll see a range of where your x values could be, and you choose one of those numbers, left or right, to graph it. And now let's go ahead and do the first one. So we have y equals x squared plus 4x minus 5. First thing, we find our axis of symmetry, meaning x is equal to, oh, sorry about my marker, is equal to negative b over 2a. Negative b, so negative, b is considered the number right here, so it's a positive 4. So it's 4 over 2a, so it means 2 times whatever a is. In this case, a, number in front of x squared, is just a 1, it's not 0. If I simplify this, I get negative 4 over 2, which gives me x is equal to negative 2. That means if I were to draw a dotted line, my axis of symmetry, meaning it's going to be that circle, that u is going to be exactly symmetrical at the negative 2. So I draw my dotted line, a vertical line, that's what x, to draw an x line, that's how you'll do it, vertical, straight up and down. Next thing is, you find your vertex. To find your vertex, you have your x's, plug in your negative 2 in place of your equation here. So then you have y is equal to x squared, or negative 2 x squared, or negative 2 squared, plus 4x, or 4 times negative 2 plus 5. You're putting this in place of all your x values here. You only have 2. And now when you simplify it, negative 2 squared is 4, positive 4. 4 times negative 2 is negative 8, and then plus 5. So you're going to have 4 minus 8 plus 5. You add it all together, and you have about 1. And now your coordinate, because it has to be a coordinate. So you have your x being negative 2. Now your y is 1. So if I were to graph that, negative 2, 1 will be right here. That is my vertex. That's my main point. Third step, you graph a point, which is your y-intercept. It's your 0, comma, your constant. In this case, your constant is your last number here. It's the number by itself. That's what constant is. There's no variable next to it. And that is 5. So that means if you graph 0, 5, you don't move left or right. You stay at 0. You move all the way up, and you move at 5. That's your second point. You're going to be plotting 3 points before you plot the whole thing. And the fourth one is here. You're choosing an x value left or right from the vertex. X values, meaning you're focusing on all this line here. You're not focusing on the y-axis. You're focusing on here. So if I focus on a number, I think the book has, they used negative 2. I'm not going to use -2. I'm going to use a different one. What did I use? I used -1. So if you look here, I'm choosing one value to the left or right. I always choose one value to the left. So if I have -2 as my axis of symmetry, my line is here, I'm going to choose one value here. So I'm going to choose this -1. What that means, I have x equals -1. I'm going to plug this -1 and place my original equation. So I'm going to do it once over again. So I have -1 squared plus 4 times -1 plus 5. And then I solve for it. So then I have y is equal to 1, -1 squared is 1, minus 4 plus 5, multiply it out. And then I have y is being equal to 2. And now my coordinate, because it's a coordinate, it's not just a number here, I have -1 and 2. You can use -1, I can use -3, I can use -7, but I always try to use one number before or after from the vertex there. But you're only choosing a number from the x-axis here. So now my other coordinate I'm going to use is -1, 2. I'm going to plot the point over here. I do the same thing on the other side. So this is 1 unit away from the axis of symmetry. So it's 1 unit away. So that means I'm going to plot the same exact point 1 unit away to the right. So you can do 1 unit to the right, 1 unit to the left, exactly at the same place, because a parabola is considered symmetrical, meaning if I were to fold this, it should touch, the sides, the lines should touch at both sides at all times. And then when I create my parabola, I have something like that. Next one, y is equal to 3x squared plus 18x plus 3. First thing, find your axis of symmetry. So I have -b, so -18 here, negative. My b over 2 times a. A is considered 3. I end up with -18 over 6, and then x is equal to -3. So I have my axis of symmetry at -3. I'm going to go ahead and draw my dotted line. And this just shows me that's where my graph, if I fold it, it's going to fold at that line. Next thing, find my vertex, meaning I just plug in what my x is. So y is equal to 3x squared, or 3 times -3 squared, plus 18x, or 18 times -3 plus 13. And then I solve for it. Y is equal to 3 times -3 squared is positive. Always keep in mind it comes out as a positive when you're squaring a negative number. 18 times -3 is -54, and then plus 13 in the end. And when I add it all together, I end up with -14. Meaning my vertex, it's a coordinate. It's going to be x being -3, and then y being -14. So -3, -14. My vertex is right here. Third, find my constant, or my y-intercept. My constant is the last number. That means my y-intercept is 0, 13. That 13 is positive. So that means 13 will be about, right here, I'll make it really big. So I have 1 point, I have 2 points. Now to find the last one, which is step 4. I choose a number, so this is my line. I'm choosing a number 1 to the left or 1 to the right of it. And the one I chose is -2. So I chose 1 to the right of it. So then I'm going to have x is being equal to -2. I'm going to go ahead and solve for that. So my equation is y is equal to 3 times -2 squared plus 18 times -2 and then plus 13. So I'm doing it once over again so I can have one other coordinate. And now I have y is being equal to 3 times 4 minus 18 times -2. I get -36, and then 13 is just in the end there. And then now when I add all this, 3 times 4 is 12, minus 36 plus 13, I end up getting -11. So my coordinate will be -2, and then from what I just solved for, -11. So -2, 12, 10, so -11 will be just about over here. Remember, it's 1 unit to the right, it's also 1 unit to the left, so I'm going to put my dot there as well. So now when I create my line, and the book has it a lot better, that's why I prefer the book. But that's how you'll graph it from there. When you're graphing these, I want step 1, 2, 3, 4 on your graph. If you just show me a picture of a graph and you don't label any of the numbers, I am not going to count that, I'll just give you a 0. You need to make sure you have all the numbers down here and you have all the steps down there. Even if you say, oh, I already know how to graph it, I need the steps down. That shows me that you graphed it and you took time to graph that. Example 3. So one more, well, two more. Y is equal to 5x squared plus 4. So now let's go ahead and find our axis of symmetry. So x is equal to negative b over 2a. If you notice here, the b is the number in front of the x. We have an x squared and we have a plus 4, but we don't have an x. So we don't have we don't have a number there. We make it 0. You have to add something there. And now it's negative b over 2a. So that means negative b. B is 0 now. 2 times a. A is considered a number in front of the x squared. So that's 2 times 5. If I go ahead and simplify, I have x is equal to negative 0 over 10. But anything divided by 0 will give you 0. So my x is 0. That means I can't really draw a dotted line, but my dotted line will be right here at the origin. Now let's go ahead and find our vertex. Finding our vertex, you plug it in. So y is equal to 5x squared, or 5, 0 squared, plus 4. 0 squared is 0. 0 times 5 is 0. So then you have y is equal to 4. And I'm not looking for y, I'm looking for my vertex. My vertex is 0, comma 4. So I have 4 as labeled here. I have increments of 2's. I'm not going to label it all for the sake of my marker. But here is my vertex. So I have my axis of symmetry, that's my line cutting in half. I have my starting and ending point right here. And now let's go ahead and do the third one, finding our y intercept. If you noticed, our y-intercept is 0, comma c. Our constant is 4. And I already have a dot there from my vertex. So that, I have the same dot there. Just going to go over the same one. Now my last one is to find one point. To find a point, I'm looking at 1 unit to the left or 1 unit to the right of this axis of symmetry line, right here. So 1 to the left, let me see which one I did. I chose 1. So 1 to the right here, I chose 1. You can choose a negative 1. I've been focusing on the right side. It doesn't matter which one you focus on. So I'm going to choose x is equal to 1. If x is equal to 1, I go ahead and plug it into my equation. So I have y is equal to 5 times 1 squared plus 4. 1 squared is 1. 1 times 5 is 5. 5 plus 4 is 9. So my new coordinate is 1, comma 9. Remember, it's a coordinate. It's not just what x is, what y is. So I have 1, and then 9, 2, 4, 6, 8, 10. So 9 is going to be about here. If it's 1 unit to the left, remember it's 1 unit to the right. And this is negative 1. So 1 unit from the vertex is negative 1. And now, if I draw my coordinate, that's horrible. I have this right here. Again, make sure you label all of them. If you're not labeling, that means you weren't listening to the video. You're just doing your own thing. But here, you have this. Example 4, I'm not going to show you because it's too much work of me drawing those graphs. But example 4 talks about the zeros. Naming the zeros of the functions, all that simply means is when you're trying to find a zero for a parabola, it's just showing you where that line hits the x-axis. Keep in mind, the x-axis is the horizon. It's going from left to right. So let's go ahead and look at the first graph. If we look at example 1, and if we look at the graph, if you notice, this parabola does not hit this x-axis, so this one has no zeros. So there's no zeros whatsoever. Let's look at example 2, we graphed it. If we look at this parabola hits the x-axis twice. It hits it here, and it hits it here. So that means my zeros are equal to, this is negative 5, and this would be negative 1. It hits at 2 locations, that's considered my zeros. And then for my third one, the parabola does not hit or does not meet at this x-axis, so this one also has no zeros. And your book has 2 more examples, or 3 more examples of showing you if it hits it or not, and you can look at that. But it simply means, where does that line hit the x-axis, and does it hit it? Does it hit at 1 point, 2 points, or 0 points? That's the main one. Example 5, last one. The reason why we do parabolas, especially for word problems, it deals with velocity and how high it can go at a certain number of times. So here we have a baseball. It's thrown up in the air, and initial velocity of 50 feet per second. So you throw it really fast, you throw it up in the air. This is the equation to show you, to see how far it's going to get up there and meet that maximum point. Because when you throw a ball, it goes up and it goes back down. So it's a parabola. So here it says it's thrown at the velocity of 50 feet per second. The ball leaves the player's hand when it is 4 feet above the ground. So he throws it, and after a certain number of time, it hits at 4 feet above the ground. And here it's saying, at what time does the ball reach its maximum? Meaning you throw it, it's hitting that maximum point. They want you to find out what's that maximum point before it starts declining. To do that, we have this equation. This is a normal equation. We use this all the time. You actually see this a lot in pre-calculus and in algebra too. Here we have the basic standard equation. We're trying to find the height, the maximum height. So that's our h. We have our negative 16t. Our t is considered our time. V here is plus v times t. V is considered the velocity. It's a velocity of 50 feet per second. And our seconds, it says after 4 seconds. After 4 feet above the ground, it's throwing a number of time. So now we have this equation here. We're going to go ahead and solve for it. And we solve for it by solving for our x-intercept. So when you're trying to find the maximum height, you're focusing on your x. You're focusing on your axis of symmetry. You're focusing on this equation here. Now, we can go ahead and solve for it. X is equal to negative b. B is considered 50 over 2 times a. A is considered negative 16 feet. If you think of it, whenever there's a negative in front of the x squared or t squared, it creates an upside down parabola, and that's exactly what it looks like when you throw the ball up in the air. You throw it up in the air, it goes up, and then it goes back down. Now, we go ahead and solve for it. We have negative 50 over 16 times 2 is negative 32. And then they want a certain number of time, and I have about 1.5625 seconds. So negative 50 divided by negative 32, positive answer, you get about 1.5625, 1.56, about a minute and a half. It would reach at that point up there. So that's what they want you to find here. You simply use the axis of symmetry formula to go ahead and find for it. That will be a part of your homework too. Make sure you look at everything in the form, not just the first 2 or 3. If you need any more help, let me know. Bye-bye.